Let's talk about rate of change. We all know that rate times time equals distance. That's a wonderful formula if you're moving along at a constant rate and you take a certain amount of time, you know how far you go. If you're going 60 miles an hour and you go for half an hour, you travel 30 miles. But what if you're not going at a constant rate? What if you're speeding up and slowing down? Then what can you say? Rate isn't just a number anymore. It's a function. It's something that's changing. And all we can say is that the average rate times the time equals the distance. If you've traveled 30 miles in the last half hour, then you average 60 miles an hour, even though maybe you were going a little faster sometimes and a little slower other times. So what we can say is average rate is always the distance traveled divided by the elapsed time. Now, in calculus, we often use the Greek letter delta to mean the change in something. So if x is your position, then the distance traveled is how much your position has changed. So we write that as a delta x. And the elapsed time is the change in the time t. So this is how we're going to figure out average rates of change. It's the change in the output divided by the change in the input. So let's look at a specific example. Let's suppose you're driving down the road, and at 1 o'clock you're at milepost 50, and at 1:30 you're at milepost 73, and so on. And you want to know how fast you are going at 2 o'clock. Now, if you're driving along at 2 o'clock, you might want to do an experiment and say, let's just keep track of how far we go in the next hour. And by 3 o'clock, you'll have gone an extra 70 miles. And it took you 1 hour to do that. And so you say, hey, that's 70 miles per hour. But that's not your speed at 2 o'clock. That's your average speed between 2 o'clock and 3 o'clock. If you want a better estimate, you'd say, let's only average over the half hour between 2 and 2:30. Between 2 and 2:30, you went 33 miles. It took you half an hour to get there. That's 66 miles an hour. Between 2 and 2:15, you went 16 miles in a quarter hour, so you averaged 64 miles an hour. Between 2 and 2:06 is a tenth of an hour after 2, you went 6.1 miles in 0.1 hours, so you must have been averaging 61 miles an hour. Between 2 and 2:01, you went 1 mile in a 60th of an hour. That's averaging 60 miles an hour. Now you've got a pretty good sense of how fast you were going at 2 o'clock. Now you can do the same thing by looking in the past. In the last hour, an hour ago, -1 hours from now, you were -50 miles ahead. In other words, you were 50 miles behind where you were now. -27 miles half an hour ago. -14 miles a quarter of an hour ago. -5.9 miles 6 minutes ago. -1 mile 1 minute ago. We can fill in the rest of the table. And we see that for the last hour, we averaged 50 miles an hour. For the last half hour, we averaged 54. For the last quarter hour, we averaged 56. For the last 6 minutes, we averaged 59. And for the last minute, we averaged 60. So how fast are we going right now? I don't know. We get a pretty good estimate by seeing what these numbers are getting closer and closer and closer to. So if I had to guess, I would say that right now we're going right around 60 miles an hour. Okay. Now, you can't do that by plugging in directly. We've gone 0 miles in the last 0 hours. You can't get 60 by doing 0 over 0, but you can get an approximation by taking the average speed. So the idea is the average speed is the change in your position over the change in time. The instantaneous speed, your speed right now, is a limit as we average over shorter and shorter periods of the change in the position over the change in time. Okay. We're going to see this limit come up over and over and over again in different contexts.